Okay, grade 10. So we're on page 209. You're welcome during class time to use your cell phone as a calculator. That being said, I really encourage you to bring your calculator. Like, I get it if you forgot it at home, it's another thing to bring. Your cell phone will work. It's not as convenient, and the sequence of buttons you press is really wonky. I say that for iPhones. I don't know Androids, but it just seems backwards to me, the buttons you have to press, versus it's different on your calculator. It's really good and required. Like, part of the curriculum, like what I have to teach you is how to use your calculator. On your test, you cannot ask me what buttons to press on your calculator. It's an expectation, you know that. So it's good for you to have your calculator with you so that way you can learn how to use your calculator during class time. First class, so last Friday, we did those first two examples that had these same two triangles where we noticed every time we divided our opposite side by our adjacent side, so the tallest side by the horizontal side, on a triangle that had an angle of 35 degrees, we noticed we always got this ratio of 0.7. The second example, when we divided those same two sides, we noticed we always got a ratio of 1.6 for a 58-degree triangle. So, like I said, the ancient Greeks back in the day, this is how they filled their time. They were super cool people, and they drew triangles, and they divided the lengths by the lengths. And they noticed these patterns. Sure. So then they came up with SOHCAHTOA. So that's what we were talking about last time. So the sine, cosine, and tangent. And so they said when we divide, so on the examples we did before was our tangent ratio, so the opposite side divided by the hypotenuse side. Can you turn it down a little bit, Angelica? So they did, no, turn the fan down. The light's off too, is fine though. So grade 10, like I said last class, they used to print the answers for all of these ratios so that you could look up every single possible triangle, the degrees, the ratios. Now we have beautiful calculators that will do this. So on your calculator, I want everyone to, oh, there's a couple steps. I want everyone first to press tan and then 35. It might be 35 and then tan, depending on your calculator. You should get 0.7. If you don't, raise your hand and I will come to you because there's a couple things I will need to check. So check the orders. So to 4 decimal places, when we do the tan 35, you all should have just seen we get 0.7002. I want you to go in your calculators now and type in the tan of 58. I fixed it. It's fixed. You should be good. Yeah. Nope. So you're going to do 58, tan, depending on, or tan 58, depending on what device you're using. You should get 1.6003 because it wants 4 decimal places. Okay, I want you to go through class example 1. Find all 4 of those in your calculator. So you're going to press sine of 35, sine of 58, cosine of 35, and cosine of 58. So you're doing this to 4 decimal places. So this is basically practice pressing buttons right now.
My 4th decimal place has a few differences. Does that really matter at that point?
Yes, it means you're rounding wrong. So be really careful with your rounding. If you're on your phone might have rounded it for you, and sometimes phones will do it wrong. So your decimal places should be exactly correct as mine. Assuming I've copied them from the workbook, so maybe the workbook's wrong. Make sure you're rounding correctly. So you look at just the number to the right of the 4th, so the 5th decimal place. If it's 5 and above, we round up. 1, 2, 3, or 4, you leave it as is. So check that you got the same 4 answers as me. So you're rounding incorrectly. Okay, so which one? Which one, Gavin?
Oh, no, I just didn't put the last name.
Oh, okay, so 4 decimal places.
Yeah, I know. I just didn't round.
Oh, you just cut it off. So grade 10s. You are in grade 10. You need to round correctly. I will mark questions wrong if you round correctly or if you just cut it off. That's not how you provide correct answers. You should know that by now. I get that if we're just having like a moment and not thinking about it. But for the future, you have to round correctly.
Were you ever one of those teachers that was like, you won't carry a calculator everywhere?
No. I've always carried a calculator with me. I'm young enough. Okay, turn the page. Turn the page. So we're going to talk a little bit of background information. This is really where some of like our IB is coming into play. Public schools or non-IB programs probably won't go into what we're about to. So we're going to compare triangles right now and make generalizations. So all of the triangles we're going to draw are going to have a hypotenuse that has a length of 1. So that could be like 1 inch or 1 centimeter, right? So it's like 1 unit. If I was to draw one like this, where that's 1, this angle, is it going to be, for that to be a steeper point, is that angle smaller or bigger than the 35? So this angle here, does this angle become larger or smaller compared to my 35?
It's proportionately higher up, so maybe they'll have a larger angle. Sure, you're right.
Okay, look at the two that are drawn. This might help. 58, so what Camden just said, 58 is larger than 35. So as my angle increases, what else increased?
The height of the.
Good, what do we call that side?
The leg.
Hypotenuse is the angled one.
The opposite. So hypotenuse. Grade 10s, let's write this down, please. Adjacent. So as that angle's increasing, keeping our hypotenuse measurement at 1 or 1 centimeter, we see our opposite side is also increasing. What that means is our sine ratio is going to also increase and our cosine ratio will decrease. Why is that? So let's think, we're not going to talk about this for a second. Our sine ratio, remember, let's go back, SOHCAHTOA, is equal to our sine ratio is equal to our opposite over our hypotenuse. So our opposite side is getting larger. So our numerator is getting bigger as that angle increases. Does that make sense, like from those diagrams? Right? If that angle is getting like steeper upwards, that other side has to grow in order to complete the triangle. So if my numerator is getting bigger, our sine overall is going to get a larger value. Versus if I look at our cosine ratio, which is our adjacent over our hypotenuse, our adjacent value is getting smaller, right? Looking at these two diagrams, I have a much longer adjacent side and then a shorter adjacent side. So if my numerator gets smaller, my cosine value is going to get smaller. If we look at the tan ratio, which is opposite over adjacent, my opposite value is going to be increasing as my adjacent side is decreasing. So I'm getting a bigger number divided by a smaller number. So that's going to cause our tangent ratio overall to also increase. So doing this is just to get you guys thinking a little bit more about the meaning and thinking a little bit more about the division, thinking about why. That's the only point. with those pieces in mind, so we're talking about as my angle's increasing. Let's look at some examples here. So if we're not using a calculator, which ratio is going to have a greater value or closer to 1, right? Because usually these are all going to be decimals. The sine of 14 versus the sine of 20. So as my angle got bigger overall, the opposite side's getting bigger, so the sine of 20 is going to have a bigger ratio value. When I compare tangents, the bigger the angle, the larger that ratio, so the tan of 75 is going to be larger. The cosine of 7 degrees versus the cosine of 62. So as cosine, as my angle increases, that adjacent side is going to shrink. So cosine of 7 is going to actually be the larger one. So remember with cosine, it's the opposite because we're talking about our adjacent side. And as that vertical side got bigger, my horizontal side here is getting smaller. So I have a smaller number divided by 1. So then that ratio overall in value is getting smaller. Go ahead, Camden.
So could you just say that sin or sin?
Sine. Sine.
If it's sine. Yeah, I can say that should have a G. So that's I. Did you say G? No, like sine. A G. Wouldn't that be C?
Ask your question.
No, the reverse. Okay. So sine. So whichever number is bigger on sine is the one that has a greater value, and
yes,
on cos.
Whichever has a smaller.
And then tan, the bigger one is
again. Yeah.
I know.
No, you're right.
Wait, what am I up to?
Don't. No, thank you. So where this gets to be more complicated, we're going to compare 3 of the same angles. So the sine of 80, the cosine of 80, and the tangent of 80. So here, I know between sine and cosine, my answer, it's a bigger degrees, so sine's going to be larger. Because in order to get an angle of 80 degrees, it's going to be a fairly steep triangle. So in order to match it up, it's going to be like a triangle like this, where this is really small up here to be 10 degrees, because these are all 90-degree angles, right? So my opposite side here is going to be a really big number. So I'm going to have a really big number divided by the hypotenuse. So my sine has to be bigger than this littler side. So sine has to be bigger than cosine. But then I'm looking at my tangent, which is my opposite divided by my adjacent. My adjacent side is smaller than my hypotenuse. Do you guys agree? So that answer, the tan of 80, is going to actually be the largest. So that, because that adjacent side has to be so short compared to my hypotenuse, that's why the tangent's ratio is going to be larger than your sine ratio. So this is really, like, questions like this are really our higher level questions, right? You're really having to understand the proportions and drawing triangles and what the shapes mean, what the ratios mean, to be able to answer these. So questions like this in general, I could have designed like an investigation about it, but these also would have been like, excuse me, a really good like level 7-8 question. Yeah. I've actually posted it to be the Wednesday because I felt really mean giving you a test period before Christmas break.
Oh, that is so mean.
So I took a review period away so that way we could have like a fun class and do your test a day earlier. Andy. Totally. If I can get access to it, but we could totally watch a movie.
Watch New York. Home Alone with Donald Trump.
Okay, turn the page. So I don't love how your calculators do this. Sorry, how your workbooks do this. We're going to skip a little bit. So to determine an angle, turn the page. 211. Just turn the page.
The thing you're on is what we are on this thing.
Okay, so grade 10s. Cross off, we're going to write other stuff in this blank because I don't like how your workbook does this. So in this space, cross that off. Put a title. To find angle in degrees. So to do this is what you have to do in your calculator. Your phone is different. So this is in your calculator. You're going to press the second button. And then you're going to press your trig ratio. So it'll be like cosine, whatever, tan. And then you're going to enter in the ratio. So what does this mean? We'll go through an example. So if you were given the tan of x is equal to 1.2, the question would say find the angle in your calculator. You're going to press second, then tan, and then 1.2. Depending on your calculator, you might have to actually press equals. Once you do that, you're going to find the degrees. Yeah, so your calculator screen is going to show it like this. And that means the inverse of tan. Basically, you're undoing that ratio. So I want you to try this. You should get a value of 50.194. Let's just round that to one decimal place. So 50.2 degrees. So try that and make sure you can do that on your calculator. Each calculator is a little bit different. So those steps are for the Texas Instrument graphing calculators. So like on this one, I press second, and then I would go tan, 1.2, and that doesn't work. So I think it's 1.2 on here, and then I press it. Did it cut off? Because it should be 50.19. Okay, grade 10s. With that in mind, I want you to do the following. So class example 5, I want you to try on your own. Notice it says the measurement of acute angle to the nearest degree. What is an acute angle?
Less than 90 degrees is small.
Good. So listening, an acute angle less than 90. All of your answers, that's a hint. All of your answers should be acute angles. So I want you to try these 4 on your own to the nearest degree. Generally speaking, degrees are always whole values because a degree is so small. We generally always round to the nearest whole degree. So I want you to try these 4 on your own. So it's the same process. You're still going to press inverse or second sine. Second cos, second tan, second sine. You're still going to do all of those to find that angle. Gavin. I'll come help you. Okay. So try these 4 on nearest whole. So our first answer, 21 degrees. Tan of P, 73 degrees. Cosine of B, 57. Sine of C is 30. How do you put a fraction? Just do the division. So you would look like the sine of 1 divided by 2, or you could do the sine of 0.5. Okay? Raise your hand. Are you 4 for 4?
Let's go.
Okay, and that's, gentlemen, that's why your phones are so hard with this one, because it's so much harder. You really want to be bringing a calculator. You have a different phone. Apple phone, it's not very helpful. Okay, grade 10, turn the page. We're gonna skip that page.
Skip it.
Yeah, we're gonna skip a lot, and then I'm gonna come back to it.
5
No.
to 14.
You know what, actually? I want you to try these practice questions, and I'm gonna come back to those. I think we need to practice this and understand this a little bit better, and then I'm gonna come back to the other ones. So let's try our practice questions, and we're going to come back to those other 2 pages to talk a little bit more. Page 214. So let's try these ones. And then I'm going to come back to the other pieces, I think. You're doing practice questions for a little bit.